So I'm going to work an additional example from section 2.5 where we calculate the probability for an event in a sample space with equally likely outcomes. And we're going to just count the number of outcomes in our event and the number of outcomes in our sample space to calculate the probability. But in order to do that, we need to list out the sample space. So let me go ahead and read the problem. So this problem says that a history professor gives out a study guide listing 5 essay questions. She will randomly choose 2 of them for the midterm. If Jean knows the answer to 3 of the essay questions, what is the probability she knows? A, both questions that appear on the midterm, exactly 1 question that appears on the midterm, at least 1 question that appears on the midterm. Okay, so to tackle this problem, the first thing that we're going to need to do is to write out our sample space. And so we need to be kind of careful about the notation that we use that can make this a little bit easier to solve. So there's going to be this list of 5 essay questions, and you could just think of it as a list of questions 1, 2, 3, 4, 5, whatever the question is for each of those. And the instructor is going to choose 2 of these to put on the midterm. So the midterm is going to look like she chose questions 1 and 2, or she chose questions 1 and 3, or 1 and 4. But one thing that we have to keep track of is that Jean knows the answer to 3 of these, and she doesn't know the answer to 2 of them. So I think an easier way to write out the outcomes in the sample space is to renumber these questions using this notation. So K1 is going to stand for the first question she knows. K2 is the second question she knows. K3 is the third question she knows. D1 is the first question she doesn't know, and D2 is the second question she doesn't know. So it could be that she knows this one, she knows 2, 3, and 4, and she doesn't know 1 and 3. And so K1 would be 2, K2 would be 4, K3 would be 5. So it's just a convenient notation. So this is the first question Jean knows, and the D1 stands for the first Q or question Jean does not know. Now the test is going to look like things like K1, K3, or K1, D1, and so on. And what we're going to do to write out the sample space, which consists of all the tests that could be made, is we're just going to list the 2 questions. We're going to do it systematically. So first we'll list the tests that would have K1 on them, and they're going to have K1, K2, K1, K3, K1, D1, K1, D2. And then we're going to go ahead and list the ones that have K2 on them. So those would be K2, K3, K2, D1, K2, D2, and just go systematically writing these down. So notice we aren't going to write down K2, K1 because we already had K1, K2. Okay, so let me just write out the sample space. So the sample space is going to be K1, K2. So that's 1 outcome. It has 2 questions on it. K1, K3, K1, D1, K1, D1, K1, D2, K1, K2, K1. Okay, just double checking here. Now I'm going to go with the tests that would have K2 on them, and I don't want to put K2, K1 because I already have K1, K2. So K2, K3, K2, D1, K2, D2. So just following these paths, K2, K3, K2, D1, K2, D2. And then the tests that have K3 on them are going to be K3, D1, K3, D2, K3, D1, and K3, D2. So these. And then the very last one is going to be D1, D2. Okay, now we can calculate the probabilities of the events that we're asked about. And the first one is the probability that she knows both questions that appear on the midterm. So that means that both of the questions are Ks. So for example, I'll highlight in yellow the outcomes where she would know both of the questions. K1, K2, she knows both. K1, K3, she knows both. Not K1, D1, because she would only know 1. And then K2, K3, and none of the others. So we end up with this probability for part A. Probability, she knows both. Let's let that be event A. A is the event. Jean knows both. We can write out the outcomes. K1, K2, K1, K3, K2, K3. And the probability of this event, A, is the number of outcomes in A divided by the number in the sample space. If you look back up to the sample space, I'll just go through and count these. I'm going to put check mark by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 equally likely outcomes in S. So we get, for this probability, 3 outcomes where she knows both out of 10, or 0.30. For part B was the probability she knows exactly 1. So if we go back to the sample space, we can figure out what outcomes are in the event she knows exactly 1. I'm going to circle the outcomes where she knows exactly 1. So it's not K1, K2, not K1, K3. K1, D1 works, K1, D2, K2, D1, K2, D2, K3, D1, and K3, D2. So there are actually 6 outcomes. So it's the number of outcomes in the event divided by the number in the sample space. So 6 out of 10, or 0.60. So the circled outcomes are in this event. And then the last question is the probability she knows at least 1 question. So for part C, let's let the event be that she knows at least 1 question. So that event, let's call that event B, C. So the probability of event C is going to be the number of outcomes where she knows at least 1 over the number of the sample space. We know the number of the sample space is 10. So let's go back up, and where she knows at least 1 outcome, I'm going to put a slash through those with purple, where she knows at least 1. So at least 1 could be 1 or 2. So K1, K2, K1, K3. Okay, so all the ones where I put a slash, she knows at least 1 question. There's only 1 outcome that is not in that event, and that is this D1, D2, and I don't actually want to circle that. So we actually have 9 outcomes in C. Those are the outcomes with a slash. And so that's 0.90.